Hello and welcome to the channel. My name is Shiki and today I would like to welcome you to the first episode of the Kubernetes saga. And I don't know if saga is the right word because it's going to have a lot of episodes, but there's a reason to why I'm starting a new series based on Kubernetes, and that is because we're going to need to know Kubernetes in the Path to DevOps series. So for now, we're going to pause the Path to DevOps journey for a few weeks until I teach you all you need to know for Kubernetes to get up and running. And then, after we know how to work with Kubernetes and we understand the technology, we can get back to Path to DevOps and start deploying our 3 microservices into Kubernetes using a pipeline in Azure DevOps. So, if this sounds fun, then follow along on Kubernetes right now, and then we'll catch up on Path to DevOps. One final thing before we begin, Kubernetes is a container orchestrator, so I would highly recommend you understand what a container is before jumping into Kubernetes. And for that purpose, I have 2 other videos on this channel, which will be linked at the end of this video as well. So jump into that first, learn about containers, understand them, and then let's get back to orchestration. Let's start with an extremely high-level example, one that doesn't even involve IT at all. It actually involves football. And as you can see here on this football field, if you take 11 random people and you put them in a position, well, this is how they look, right? But some of them might be faster than others. Others might have better reflexes. Some of them may be better at dribbling the ball or sprinting for a short period of time. Well, if you show that to someone else, maybe a coach, then he would be able to ask these players to take a certain formation and maybe actually have a chance at winning a football game. Well, that's exactly what a container orchestrator does. The players are your containers, and the coach is actually the brain of your container orchestrator, which notices different behaviors and patterns in your containers and tries to allocate them or assign them certain positions so that they function properly. This is extremely high level again. So let's move into a more IT-related example. Let's check out these 8 microservices packaged as containers, and let's say we want to start them as a full stack of applications, and we're going to do that on our local machine. The problem here is if our local machine goes down, then everything is dead. And if something fails, how do we know it failed? Questions like these are what a container orchestrator tries to solve. And the first one, how do you recover from failure on one machine? Well, that's simple because the container orchestrator almost never uses only one machine as a backend. It's basically something like this. It has a pool of multiple nodes, and your containers will run on all of these nodes spread out, but they will still be able to communicate with one another. And that's the beauty of it. Basically, if you lose one of the nodes, your workload will migrate onto the remaining ones as capacity allows. Yeah, so if you have free CPU or memory, your applications will migrate from the failing node into one of the good ones. There are a lot of constructs that Kubernetes employs under the hood in order to make sure that your containers are running and that they are properly orchestrated and functional. I will mention some of them, but we'll go into detail later on in the course as we reach those chapters. First of all, we have service discovery and load balancing, which basically ensures that containers can find one another, they can communicate to one another based either on DNS or on IP addresses. We also have types of storage, different types of storage that containers can use in order to store valuable information, which will not die with the container. It will persist in the cluster. It can also try to ensure you have minimum or even 0 downtime through several mechanisms of rollback and rollout. It also tries to self-heal. Whenever a container dies, it tries to bring it up and make it functional. And also it has secret and configuration management so that your application has everything it needs inside of the Kubernetes ecosystem. And now on to the most important part of this episode. How does Kubernetes work under the hood? So there are 2 major constructs you need to know about, and those are masters or
head nodes or control plane, all these three terms are synonyms, so we'll call them control plane at the moment. And nodes. These are the two constructs you need to understand. The control plane is the brain of the cluster. It basically manages all the other resources and tells them what to do. And then the nodes are the muscle of the cluster. They do the whole work. They actually instantiate and run your workloads. Yeah, so when you're trying to run an application in Kubernetes, your application is going to be run on a node, not on the control plane. The control plane has specific objects, specific technologies which ensure that the cluster is functional, but the control plane does not or should not run workloads. One more thing, I know here you have two nodes and one control plane. Don't get scared by this. I recommend that for a production build of Kubernetes, your control plane is highly available, which means you have multiple instances. Yeah, you have multiple virtual machines, multiple hosts running the head node, the control plane, the master code, the master applications, and then you obviously have more nodes than just two to run your workload. But you need to make sure that if something happens to one of your head nodes, to one of your control planes, your cluster is still up and running and is recoverable. Yeah, because if you lose this and you only have one instance of it, you lose your whole cluster. Okay? Good. Moving on, let's talk technologies inside of these constructs. Starting with the control plane, we have the big front door of the cluster, and this is the API server. This is the only component that's exposed externally. So if you want to communicate with Kubernetes, you're talking to the API server. When you're trying to create a pod, you're talking to the API server. When you're trying to get logs from a pod, you're talking to the API server. Basically, anything you want to do using kubectl or a library or native commands or whatever, you're doing that through the API. Okay? And this API implements all of the Kubernetes objects. It means inside of it, it has the definition for everything. It knows what a pod is as an object, what a service is, what a deployment is, what a node is. Everything exists inside of the Kubernetes API. Okay? Moving forward, we have the scheduler, the second component on the control plane. And this guy has the job of putting work onto nodes. When something new appears in the cluster, a new pod needs to be created, the scheduler looks at the nodes in terms of capacity, in terms of CPU available, in terms of memory, and the scheduler decides where to put that pod, on which of the nodes that are available. Following this up with etcd. etcd is the store of data for the Kubernetes cluster. If this gets corrupted, you lose your cluster. Okay, it's a key value store. This is very important. Key value pairs. Yeah, it's a NoSQL database and it's highly available. Basically, all of the state of the cluster is stored inside of etcd. Very important component. Again, if this gets corrupted, you might not be able to recuperate your cluster. Next component on the list, controller manager. You don't know that yet, but a controller is something that takes care of a particular type of resources. Yeah, so you have, for example, a pod controller, which takes care of all the pods in the cluster. You have a deployment controller, which looks at all the deployments, and so on. You have even a node controller, which looks at the nodes. Well, this is a controller manager, which means it runs all of the controller processes. It's basically a controller of all of the controllers. Yeah, this guy right here, it controls all the other controllers. The pod controller is controlled by it. The deployment controller is controlled by it, and so on. This component has all of the controllers inside of it. Moving up, we have the final optional piece, and I'm saying optional because if you're not running your Kubernetes cluster in a cloud provider, then you will not have this. This is a cloud controller manager, and it's basically a component which allows your Kubernetes cluster to integrate itself with the cloud provider it's sitting on. Let me give you an example. If you want to expose an application from inside of Kubernetes into the internet, you will need an IP address. Well, this Cloud Controller Manager will request that IP address from the cloud provider if your Kubernetes cluster is running inside of a cloud provider. Now, let's move on to components on nodes. And the first one is the kubelet. This is basically the brain of the node. This application represents the node. It takes care of almost everything that's happening on the node, and it communicates the state of the node with the API server. One more thing I would like to mention here that I just talked about the API server. Every component, when they try to talk to one another, they don't do it directly. They all go through the API server. Okay, so this is very important. Keep this in mind. Everything in Kubernetes talks through the API server. Okay? So moving back to the node, or coming back to the node, the following component, except for the kubelet, is the kube-proxy. And if you remember in the previous diagram, I showed how all of those containers were running on different nodes. Well, how can they still communicate with one another if they're on different machines? And it's basically thanks to the kube-proxy. The kube-proxy is a component which makes it possible for individual nodes to actually link or peer their internal address space. Yeah. So inside of a node, the applications that are running inside of a node, they run inside a virtual address space. And this kube-proxy makes the connection between those address spaces in the nodes. It's basically as if they're linked, or they're just, this is one node, this is another node, and the kube-proxy allows it that the address spaces of these nodes become neighbors. Yeah, so you can actually, they get peered to one another. That's the technical term. They get peered to one another, and they can talk from this node. You can talk to this node, yeah, internally. So that's the beauty of kube-proxy. And then we have the container runtime, whose purpose is to start and stop containers. And initially in Kubernetes, it was the Docker container runtime, but that was quite heavyweight because Kubernetes does not need to be able to implement all of the features that Docker offers. So now some Kubernetes flavors, let's say, don't use Docker anymore, and they use lightweight container runtimes. But the purpose of the container runtime is still the same, to run start-stop containers. Yeah. And as I said earlier, all of these components on the nodes or even externally, if I as a user want to talk to my Kubernetes cluster, I need to do that through the API server. Yeah, this is the only externally exposed resource. Now, who's up to see this all in action in an example using Azure Kubernetes Service? I hope you're all excited for a demo, because now we're creating an AKS Azure Kubernetes cluster. So first I'm choosing Kubernetes services here on the screen, and I'm just going to create a Kubernetes cluster, nothing more, nothing less. Let's choose a different subscription and let's give it a new resource group. In Azure, a resource group is like a logical container where you store Azure resources. So I'm just putting this somewhere I remember and I will delete later. So let's call the resource group delete later so that I know what I have to do, right? I want a cheap cluster, so I'm choosing dev test one, and I need to give it a name. So let's say Shiki minus AKS, and it allows me, this is a valid name, I'm doing that. I'm based in Europe, so let me just choose North Europe for a region. I don't want no availability zones because I'm not trying to make this a production cluster. It's just for us to interact with it and talk about it a bit. This is the version of Kubernetes inside of the cluster, and I'm just going to choose the default one. I don't want my API server to be highly available. Again, it's a dev test cluster, so I'm just going to leave the one optimized for cost. And yeah, the standard offering is a bit too much for me, so I'm going to choose a different node size. Again, this is the node, not the master, not the control plane. It's where my workload will run. And I think I'm gonna go with a 2 CPU 8 RAM, yeah, DS2 V3. I'll select this one. And the node count, let's make it 3. Yeah, let's do 3 to 5. So this is going to be only one node pool called agent pool, and this is the size. It's fine for me. I don't want virtual nodes enabled. Yeah, it's fine. The encryption level they want. Yeah, sure. Local accounts with RBAC. That's fine. I don't care. And actually, to make things easier for everyone, I'm just going to go to review and create directly. Yeah, so I only chose the resource group, the name of the cluster, and basically the size of the nodes, and validation passed. So I'm going to create the cluster and obviously fast forward this until it's done.
A few moments later.
Alright, the resource creation is complete, so we can click this go to resource button, and there we are, Shiki AKS Kubernetes services created. Woo! But what exactly is this resource? Is this my control plane? Well, not really, because here it says that I need to get credentials for the cluster, and then I will be able to get the deployments in all namespaces. So basically here it's telling me that in order to connect to the cluster, I'm actually only connecting to the API service. And I know I sounded surprised, but basically that's what most cloud providers will do. They won't give you access to the control plane. You're not able to see the etcd database or data store inside the control plane. You're not able to access the scheduler or the controller manager. None of those components are accessible to you, excepting the API server address or host name. Yeah, so they give you access to your API server, obviously, so you can use the cluster, but the control plane is completely obfuscated from you. You can't see it, you shouldn't know it exists. Basically, all the control plane is for you is this purple icon here with a name. Yeah, but then you might wonder, where are my nodes? What happened here? Well, there's a node pools menu in here, and you can see the agent and that it has 3 nodes ready. But if you actually want to see the resources in Azure, you should search for resource groups, and there's a resource group prefixed with MC. MC stands for managed cluster, and there we go. MC delete later Shiki AKS in North Europe. And inside of this resource group, you will find there's a public IP address. There's a virtual machine scale set, which has 3 nodes. Yeah, these are my nodes. You have a network security group, which is basically a firewall. Route table, this is necessary to route the requests from one node to the other. Yeah, the kube-proxy will use this to route the traffic between nodes. You have a VNet in which your nodes sit, and you have a load balancer through which you can receive traffic to your nodes, to the workload which resides on your nodes. And then you have a managed identity for your agent pool to do stuff like, I don't know, pull images from a container registry, if that's what you want to do. So these are the resources necessary for your nodes to run properly. And if you're wondering where your control plane is, again, it's behind this. Yeah, this is the resource that you don't actually have access to SSH inside of it and see what's inside. It's basically an abstraction of your control plane, and from here you can control different stuff regarding the cluster. Like, for example, if I wanted, I could add a new node pool with new nodes, or I could scale this current one. Yeah, there you go. If I wanted to go to 5 nodes instead of 3, I could, or even 1000. Yeah, there we go. So that's the beauty of it. Yeah, you can control the cluster from here. You just don't get access to everything because Azure just says you don't need to know that. I'll make it easier for you to use Kubernetes. I'll maintain the control plane. I know how to do that. I'm an expert in controlling and maintaining the control plane. You just want to be a developer and develop your app and deploy it into Kubernetes. I'll make things easier for you. Here's how you use it. So let's listen to this cluster and let's do what it says. First of all, it says to set my subscription, and I will do just that. There we go. and then it also says I need to get the credentials for this cluster. And I'm also going to get the admin credentials. Yeah, so now I'm an admin on the cluster. And if we do kubectl get nodes, for example, there we go. We have 3 nodes in the cluster. And my mouse died for a moment.
One eternity later.
All right, mouse is fixed. So let's talk about what we've just done. First command, az account set, and this subscription basically changes the current subscription to the one the cluster is on. And then az AKS get credentials merges something as current context on this path. I'm kidding. I know I might sound surprised, but I'm actually not. So this path right here is where your kubectl CLI hosts its config. And yeah, let's move here. I was already there, but doesn't matter. And let's open the config with Notepad++. So it basically downloads definition of your cluster. Yeah, I have 2 clusters here. One is the Rancher desktop, which is installed on my machine. And the other one is this Shiki AKS that I just created in Azure. So as you can see here, there's a cluster definition. Here we have a user definition for this cluster, and then we have a context. Yeah, so context is a combination between cluster and user, and as you can see here, the current context is the one in AKS. Okay, so basically what it's telling me here, and I can show you via this command, kubectl config get contexts. It says that the cluster I'm issuing commands towards is not my local Rancher desktop. It's actually the cluster in Azure. And this is how you can swap from one cluster to the other. Yeah, if you have multiple clusters and you want to check them one by one, you just kubectl config get context and then kubectl config use context. And let's choose this one. Yeah. And now it's switched. So let's switch back again. This one. And now we're back to our old cluster. Okay. So now that we have merged this context here in our local config, it means we can talk to the API server because where's the config? Let me open it one more time. This is what I wanted to show you as well. You can see here the server address is actually the API server. Yeah, right here. It's the same one. Okay, so in here it's basically a set of how-tos plus authentication and authorization to communicate with the Kubernetes cluster that we've just created. All right, enough of that. So one last thing that I want to tell you is that the Kubernetes API server, the component we've just talked with to get the information about these nodes using kubectl. Yeah, so here we requested to get information about the nodes, and it's the API server that sent this information back. And we can even go more in detail and do kubectl describe nodes, and I'm actually going to describe just one of them. Let's choose this one for no reason. And now we have even more information than we expected. Yeah, so we have here its name, the role, some labels, which just key value pairs metadata. Yeah, creation timestamp. Okay, conditions, if something is corrupt or not, if it's working, addresses, IP, networking, a lot of information. Yeah, so we've just gotten all of this information about the node from the API server, which sits on the control plane. And now the final trick before we close this initial episode of the Kubernetes series is interacting with the API server via kubectl may be simple because kubectl is a wrapper on top of REST API methods. But all in all, the Kubernetes API server is a simple REST API. And if you know how to interact with a REST API, you know how to interact with the API server of a Kubernetes cluster. So what I'm going to do is kubectl proxy. This will run the API server on my local host port 8001. and I will do localhost 8001, and there we go. Yeah, these are all the paths, the resources that the API server can give us information about. And let's check /API, and it tells us it has only one version, version 1. So let's try version 1, and bam, here we have. So we have types of resources, okay? Config maps, for example. If we wanted to get all config maps, we haven't learned what those are yet, but here we have all the config maps in our cluster. Yeah, so we were looking at nodes. Let's try nodes. There we go. All the information that we've gotten in here, yeah, previously through kubectl, we can get it directly through a get REST API call directly on the API server of the Kubernetes cluster. So I hope you enjoy this trick. I don't actually use it that much, but it's interesting to understand that the API server of Kubernetes is a simple REST API you can play with.
Okay guys, thanks for taking the time to check out this video. I hope you found this information interesting, and if you want to know other stuff, then just drop a comment down below, and I'll see you on the next episode of this Kubernetes series. Cheers!